Good morning to one and all. Today we will discuss on the topic of correlation and its types. So previous classes we have discussed about that basic introduction of statistics and measures of central tendency, measures of dispersion. So let's come to that correlation part, which is in the third module. So what is mean by correlation and what are the types of correlations are there? So here, so basically we need to know that what is meant by correlation. So can anybody can say that what is meant by correlation? See, for example, some of the famous people they have given their definition about that correlation. See, according to the Simpson and Kappa, they told that the correlation analysis deals with the association between two or more variables. Two or more variables. So, according to them, the correlation analysis or correlation means which deals with the association between the two or more variables. Two or more variables. It's simple, nothing but association, nothing but the relationship between the two or more variables. So by looking at the correlation only, you can come to know that correlation in the sense the relationship between the variables. Correlation means the relationship between the variables, or sometimes we can use association between the variables. So another famous person was the Yalun Chow. So according to him, so the correlation analysis attempts to determine the degree of relationship between the variables. So as per him, so what he told that the correlation analysis attempt to determine the degree of relationship. For example, he told the previous person told that there is a relationship between the variables, but whereas Lanchal, he told that so the correlation analysis can determine the degree of relationship, nothing but how much the relationship is there. For example, I say that there is a relationship between the two persons. For example, if you take into account, so for example, if you see a person, two persons, for example, if you take into account, so a boy and girl, for example, they are walking together. So some people will see that what is the relationship. For example, they may be lover, they may be brother and sister, or they may be some relationship. So we examine the relationship between the two persons, that is called two variables. If you take it consider the boy and girl is a one variable. So like that if you take, but in order to estimate that how much the strong relation, how much the relationship is there, there is a degree of relationship between the variable, nothing but how much relationship is there. For example, if I want to take of you only, for example, you people, for example, you and your friend, for example, I want to know that what is the relationship between the two persons. You are the one variable, your friend is a another variable. So I want to know that is there any relationship. Okay, so after concluding that there is a relationship, but I want to know that how much relationship is there, how much relationship is there. Just we can call we are the good friends, we are the best friends. Just somebody will say that he's a normal friend, sir, or he's a only classmate, like that. So if there is a good friend, there is a strong relationship between the two persons. There is a just friend, nothing but there is a just a casual relationship between the persons, like that. So as per that launch out, the correlation analysis attempts to determine the degree of relationship between the variables. Then according to the aim Kutle, so as per that person, the correlation is an analysis of covariance between the two or more variables. The covariance, simple, the covariance is nothing but correlation. The correlation between the two or more variables is called correlation. Then here the correlation is a measure of association. For example, sometimes they will ask that what is mean a correlation. The correlation is nothing but association between the two variables or degree of relationship between the variables, or sometimes it can measures the association between the variables, nothing but it can measure the how much the relationship is existing between the two variables. The correlation can measure it, and it gives an figure which shows the direction and strength. For example, it gives a figure, nothing but it will give a value. On the base of value only, we can come to know that whether which direction is there. The two variables are moving, whether positive direction or negative direction, and strength of the relationship, nothing but strength, whether it's a weak relation or strong relation. Just we can call a good relation between the two persons. we can say that there is no good relation between the two, nothing but there is a weak relationship between the two persons. Like that. So the correlation which will measure the association between the variables, and the correlation value gives nothing but the value can shows the direction of the relationship between the variables, and it can show the strength of the relationship, strength of the relationship. For example, if you take into account in our economics, demand and price, demand and price. So when you take the data of demand and price, generally we can get a negative relation, nothing but as price increases, the demand falls down. As the price decreases, demand increases. There is a negative direction between the two variables. There is a demand and price. So on the base of value, we can measure the certain correlation. On the base of value, the value can shows whether it's a positive direction or negative direction. Okay. Then only if there is a negative direction, how much there is a strength? Nothing but the relationship is weak or strong. For example, if you take another example, height and weight. Height and weight. Generally, if our height increases, our weight also maybe increase. Generally, probably is there. But for example, some people, if their height is increases, their weight may be coming down. Generally, for example, as height increases, the weight of the person will be increases. Generally, we will get positive relation. But how much the relationship is there between the height and weight? Height and weight. Height and weight. Is it clear? I think, dear students, is it clear now?
Yes, sir.
Yeah. Then the main introduction of the correlation is over. Then we will come to know that what are the names of other synonyms names are there of the correlation. The measure of correlation or called the coefficient of correlation or correlation coefficient. Generally, when we are measure the correlation, it calls the correlation coefficient or coefficient of correlation. When we are measuring the relationship between the two variables, that value can be called correlation coefficient value or coefficient of correlation. The correlation coefficient, alternatively called total correlation and product moment correlation. There you can remember this. This is very important. The correlation coefficient, alternatively called total correlation or and total product moment correlation. Product moment correlation. You have to remember this is a very important point. Then the correlation coefficient is denoted by R, capital R and small r. This is very also important. The coefficient of correlation or correlation coefficient is denoted by capital R and small r. Where we can use capital R, where we can use small r. So the capital R will be used when we have the population data. Small r will be used when we have the sample data. You can clearly remember. Sometimes they will ask that. So correlation coefficient is denoted by dash. First option R, small r, capital R square, small r square. Or sometimes they will ask that capital R, small r, C option, both A and B, C, D, R square. So option is A and B. There is a C option. So simple, you can remember that coefficient of correlation alternatively called total correlation and product movement correlation. The coefficient of correlation denoted by capital R and small r. Then another important point, the R value lies between -2 to +1, -2 to +1. So when we are measuring the relationship between the two variables, we will get the value -1 to +1. We cannot cross the -1, we cannot cross the +1. So the value should be between in the -1 to +1 only. Nothing but when we are measuring the correlation value, so our value should be -1 to +1. If it is excess, we need to recheck whether our problem is correct or wrong. Okay. So sometimes we will write like this also: -1 less than or equal to R, or greater than or equal to +1. The R value, whatever you get the R value, which is equal to -1 or less than -1, or greater than plus R value is greater than or equal to 1 or greater than the, sorry, here also less than should be there, less than plus or minus to 1. Then the correlation is a statistical tool. For example, why we can study the correlation? So earlierly we have discussed about that measures of dispersion and measures of center tendency. When we are measuring that values, we have taken only one variable, that is called bivariate relationship. We have examined and we came to know that how we can use a bivariate variable, how we can estimate the values of mean, median, mode, geometry mean, harmonic mean, range, total deviation, mean deviation, standard deviation, and variance. But in our economics, generally with one variable we cannot do so much. But when we are using number of variables in our economics, for example, if you take it in economy, so there are so many variables we have, but we need to interlink them. So in order to interlink them, we need to use a bivariate relationship or multivariate relationship. So in order to study that bivariate relationship or multivariate relationship, we will study the correlation analysis. Correlation analysis. In the correlation analysis itself, it says that relationship between the two, nothing but we are considering the two variable, that is called bivariate relationship. Bivariate. And we'll come to know that how multivariate relationship are there by studying the correlation. So we can examine the multivariate relationship. So basically, in the correlation analysis, we can use bivariate relationship. Sometimes we will use the multivariate relationship also there. Then here, why we can use the correlation analysis? That is a major part. So the correlation is a statistical tool. Nothing but is a statistical technique. The correlation is one of the statistical technique which can help to measure, and analyze the degree of association or degree of relationship between the variables. Simple. The correlation is one of the tool in statistical tool, so which can help us to measure and analyze the degree of relationship between the two variables, that is x variable and y variable. So if you have the data of x variable and y variable, we can come to know the relationship between the two variables. So generally, if you take the price variable and demand variable, then you will come to know the what is the relation. There is a generally we can the negative relation exists. But we want to know that how much the degree of relationship, nothing but how much the relation, whether weak or strong. By studying the correlation only, we'll come to know that how much the degree of relationship between the two variables. Then you can note down a point, that is a causation always implies the correlation. Causation always implies the correlation, but correlation does not necessarily implies the causation. This is a very important point, that causation always implies the correlation. For example, there is a causal relation. There should be a relationship between the two variables. See, in a particular family, if somebody will suffer, the family may be suffer. That is called the causation always implies the correlation, but the correlation does not necessarily imply the causation. Nothing but if there is a relationship between the two person, they cannot affect on the others. In that case only we can understand easily. The causation always implies the correlation. If there is a causal relation between the two variables, there should be some correlation. But if there is a correlation, that doesn't necessarily imply the causation. There is a relation, but which are not uh, independent, which are not dependent, which are not dependent, which are independent, which are independent. You can say like that. Then next one, so we have discussed about that what is meant by correlation and what is the correlation value, how the correlation can be indicated or denoted, and then we'll come to know that types of correlations. There are number of correlations are there on the base of different values and directions and proportion and the variables. See, the major types of correlations are I have displayed here. See, on the base of the direction, on the base of the direction, there are two types of correlation: positive correlation and negative correlation on the base of direction. So on the base of proportion, nothing but the change in one variable to cause change in another variable. For example, there is a how much the proportion in the two variables. So on the base of proportion, there are two types of correlation. There is a linear correlation and non-linear correlation. Then on the base of number of variables, nothing but how many variables? Just now I told you that there is a bivariate relation, there is a multivariate relationship. So bivariate in the sense two variables, multivariate in the nothing but more than two variables. So on the base of variables also we have the types of correlation. The first one simple correlation, and second one multiple correlation, and third one partial correlation. You can remember this 7 along with 1 8 plus 1 8. There is a zero correlation. On the base of the value, it will get the zero correlation. See, you can remember on the base of direction there is a two types of correlation. There is a positive direction, positive correlation. Second one is a negative correlation. On the base of proportion, there are two types of correlation. First one is a linear correlation. Second one is a non-linear correlation. So on the base of the number of variables, there are three types of correlation. First one is a simple correlation. Second one is a multiple correlation. Third one is a partial correlation. So on the base of the value of the R, we will get zero correlation also. Zero correlation. So we will discuss one by one what is meant by positive and negative, linear, non-linear, simple, multiple, partial, and zero correlation. Then, so on the base of positive, on the base of direction, the first one is a positive correlation. Positive. What is meant by positive correlation? Simple here. If the two variables move together, if the two variables move together in the same direction, that is called the correlation between the two variables is called positive correlation. Simple terminology: if the two variables moves the same direction, that is the positive direction, that is called positive correlation. For example, if you take the values of price and supply, generally in our economics law of demand, as per law of demand, as the price increases, the supply of the commodities also increases. So for example, if you take another example, height and weight. See, generally height of the person increases, the weight of the person also increases. This is a positive relationship. Nothing but the two variables moving together. And third one, if you take it on agriculture, generally up to this normal rainfall, up to the see, as rainfall increases, the productivity of crop also increases. But if it is excess of the rainfall, the productivity decreases. But at a certain level only, as the rainfall increases, the productivity of the crop also increases. And if you take it up in the recent elections which are conducted in the Telangana, Dubaka, see, for example, we can conduct, there's a political economic perspective, we will collect information with regard to the number of public meetings, and number of votes secured. For example, if you take into account, in order to get more votes, so a particular party, how many meetings they have conducted in particular constituency, then how much, nothing but how many votes they secure. For example, if the number of meetings conducted, so the number of votes may be increases. Nothing but most of the people may attract. Okay, there is a political economic perspective. We will collect some information with regard to particular things also. For example, another example in our economics, see, so as a expenditure on sales and expenditure on advertisements and sales of the particular commodity. For example, if a new company is going to come, so they will do more expenditure on advertisements. So when their expenditure increases on advertisements, their sales may be increases. The sales may be increases. So that is there is a positive relationship between the two variables. Just we will come to know that by using the diagram also. See, I have taken the data, height and weight. For example, height is 5.2, weight is 56, 5.4, 62, 5.8, 68, 5.9, 71, 6.2, 72. So on the base of this data, what we can observe, there is a positive relationship between the two variables. There is a positive direction between the two variables. So generally, height is పెరుగుతుంటే weight గిట్ట పెరుగుతుంది కాబట్టి there is a positive direction ఇలా వస్తుంది, but it can be straight line. Okay. Then on the base of direction also there is another one, negative correlation. If the two variables moves opposite, nothing but if one variable moves this way and another variable moves from that way, something but there is a opposite direction, that is called negative correlation. So for example, best example, price and demand. As price increases, the demand comes down. As price decreases, the demand will increase. And another example, if you take into account, age and playing habits. For example, as the children's age increases, see, their playing habits maybe decreases. For example, see a little bit. For example, from the children age to young age to old age. So as our age maybe increases, the playing habits maybe increases starting level. But later on, if we compare with the children age to old age, so as our age increases, the playing habits maybe decreases. And best example for this is a very important point which can useful for you. Say third point example that the WhatsApp chit chat time and your grade. See, when you are using more WhatsApp for chit chat, so you maybe lose your grades also. See, when number of time if you take into account, so if you use more WhatsApp for chit chat purpose, you may lose your grades also, nothing but. So if you spend more time on WhatsApp, nothing but you are spending time on WhatsApp is increases, your grades will be decreases. Like this, there is a negative direction. Just I have shown the example of price and demand. That is, as price increases, demand will be fall down. Okay, so the negative direction will come like this. Negative. So is it clear that on the base of direction? Hello, hello, dear students. Hello, are you there?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Is it clear or shall I explain one more?
Clear, sir.
It's clear.
Okay, thank you. Then, on the base of proportion, on the base of proportion, so there are two types: the linear correlation and non-linear or non-linear correlation. So, what is mean by linear correlation? The correlation is said to be linear when amount of change in one variable tends to be bear a constant ratio to the amount of change in another variable. Think, but if the ratio of change in one variable is to be tend to be changed same in the another variable is called linear correlation. Linear correlation. For example, if you take into account the price and demand. For example, if you take into account if the price increases from 1 to 2 rupees, if the demand will be increased from 5 to 7. Nothing but see, I have shown data. See here, 1 to 2, 5 to 7, 2 to 3, 7 to 9. Nothing but here the proportion is how much? Only 1. Here the proportion is 2. See here the price in the x variable the changes in 1, and here in y variable the changes in 2. There is a same proportion in every time. See, 2 to 3 there is a 1 change. Here 7 to 9 there is a 2 change. Only here 2 3 to 4 and 9 to 11 there is only 1 change. Here 1 change, here 2 change. That is called same ratio, we can say that ratio. And when you take into account, when you plot a graph by using the linear correlation data, so simple you will have the linear relationship will be form a straight line. Nothing but when we have the linear correlation, so when we plot that graph, you will get a straight line. You will get a straight line. Straight line. See how we can get straight line also we can show on the base of this data only. See, for example, the price value 1, 2, 3, 4, 5. The demand is 5, 7, 9, 11, 13. Some people may think that why it is a one, there is a change in 2. For example, see, so if the price increases from 1 rupee, the demand is going to increase by 1. That is nothing but here I told you that price positive relation, but with respect to particular variable only. Okay. So here I mentioned the positive relation. Don't confuse that. As price increases, demand should be fall down. Okay. So in certain commodities, for example, if you take gold and gold, okay. So as the price increases, the demand for the goods also will be increases. So here the price increases by 1 unit or 1 rupee, the demand is going to increase by 2 units. So every time, see, if the price increases from 2 to 3 rupees, the demand for the particular commodity goods will be increased by 2 units. 2 units. So when you plot the graph, you will get a straight line. This is a straight line. You can say this line, this straight line is called linear straight line. Linear straight line. And here the change may be positive or negative. For example, the linear, it may be positive direction, it may be negative direction also, but there should be some linear. For example, if you take this one also, here 13, 9, if you take data opposite direction, 13, 11, 9, 7, 5, you will get like this. You will get in the negative slope. Okay. So linear correlation does not exist in economics. Generally in our economics, 99% the linear correlation does not exist in economics because there are other factors which can influence the variables. That's why then in our economics, the linear correlation does not existing in economics. 99%, but some 1% it may be happen, and other social sciences also. But exact in physical sciences. For example, if you take into account uh, the physical sciences, they can do some practice. For example, if you include something, so automatically the output will be doubled. So generally, in the physical sciences, the linear correlation will be happen. Linear correlation will be happen. Then go for the non-linear. So what is meant by non-linear? See here, it's a quite opposite for the linear. The amount of change in one variable does not bear a constant ratio to the amount of change in another variable. Nothing but here, the amount of change in one variable does not change same in the another variable. So when you plot a diagram, so we will have that non-linear relationship will form a will form not a straight line but a curve. But when we have the data of non-linear correlation, so we will get a curve but not a straight line. But when we are drawing the graph by using the non-linear data, so we will get a line, but it is not a straight line, but it is a curve only. It is a curve. See, in a non-linear, see, there is a change in if you take x variable and y variable, x variable changes in 1 to 2, 2 to 3, like there is a changes in only one. But whereas in y variable, see, 5 to 15, there is changes 10. Then again 15 to 39, there changes in 19. 15 plus yeah, 19. Then here 39 to 69, for example, there's a changes in 30. Nothing but the proportion is not same. See here, if you take this dot also, price and demand. See, the price increases by 1 unit only every time, but the demand is increases at higher level. Nothing but the proportion is very change. See, there is changes in only one. Here the change in 10. If you take the price increase 2 to 3 rupees, the demand is increased by around 24. Here there is only one change. Here 30. Here only one change. Here around 51, 61. Sorry, 61. See, this is a when you graph this kind of data, you will get a curve, but it is not a straight line. It is not a straight line. There is some. It is called curvilinear. We can say the curvilinear. Okay, this is called not a straight line. Is it understood? Linear and non-linear, dear students. Then we will go with the next one. See, we will see the graphs also there. So linear correlation, for example, the negative correlation. So there is a y variable and x variable. If you plot the diagram, you will get this kind of data. It's a negative linear correlation. It is a positive linear correlation. Then it is a I can explain the this one later. Say the curve non-linear correlation. Nothing but it is a curve, but it's not a straight line. It is a curvilinear. It is a curvilinear. So here linear relationship, linear. It is a positive. It is a negative. It is a curvilinear. It is also curvilinear. See here, the line is not a straight line, but is a curve is a curve. So here also there is a curve, but it is not a straight line. It is called curvilinears. It is a linear. Simple. When you're writing something about linear and non-linear, you can put the diagram also with the help of the data. Also, without help of the data, also you can do the you can draw the diagrams. Then here we can show that strong relationship and weak. For example, when we are plotting the straight line curve, if the actual values are very close to this straight line, nothing but this black line. See, if the dots are very close to this line, there is a strong relation. See, this is also a straight line, but the dots are not very close to this line. Compare this one. So there is a weak relationship. Okay. So this is about positive. This is about negative. In the negative also see the dots are very close to the straight line. But here whereas the dots are very not close to this straight line. This is called weak relation. This is called strong relation. So on the base of values only we will come to know the how much strong relation and how much negative relation also we will come to know the next class. Then on the base of number of variables, on the base of number of variables. So there are three types of variable correlation on the base of number of variables. The first one, simple correlation. So what is simple correlation? If there is a relationship between only two variables is called simple correlation. Here, simple correlation is nothing but if there is a correlation between or if there is a relationship between two variables is called simple correlation. Only two variables, that is called simple correlation. For example, your income and your expenditure, your income and your expenditure, or your family income and your family expenditure. For example, your family expenditure may depends on so many factors, but if you consider only two variables, that is your income and expenditure. How much your income is coming, how much you are spending amount. That is the two variables. That is called simple correlation. Whereas multiple correlation, second one, multiple. If there is a relationship between more than two variables, more than two, nothing but three or more than three also. Multiple correlation means if there is a relationship between more than two variables, that is called three variables or more than three variables, is called multiple correlation. Multiple correlation. For example, as for law of demand, the demand is depends on so many factors. That's why we can write is the quantity demand is equal to function of price, income, price of complementary goods, substitute goods, taste, preference, etc. We will write. For example, if we consider, see, I will consider four variables here: demand, price, income, taste. So if I want to know that what is the relationship between these four variables, so if I use these four variables data, if I calculate the correlation, that is called multiple correlation. Multiple correlation. Multiple correlation. Then third one, partial correlation. The partial correlation is also very important. See, sometimes they will ask what is the difference between partial correlation and multiple correlation or simple correlation. So the partial correlation is nothing but partial. Generally we can use partiality. Nothing but we can ignore. Sometimes our friends will call that. So he is maintaining the partiality. Nothing but so we will not look at them. That's why they will call is maintaining the partiality like that. So when we are measuring the relationship between the variables, so here if there is a relationship between two variables when other variables are constant is called partial correlation. For example, as we told that demand, price, income, taste, these are the variables we consider. But if I want to know that only demand and price, when we are ignoring the income and taste, nothing but they are kept constant. Nothing but we are keeping the other variables are constant. Nothing but when you are writing a law of demand, so as the price increases when the demand is increasing, when ceteris paribus or when other things are remaining constant, we will write like that. So when other things are remaining constant, nothing but so when we are keeping other variables kept constant, then we will assuming that how much the relationship between the two variables. Generally, if you take into account in the medical field, so most of the doctors will check the blood sugar levels. So before meal, after meal, nothing but in the morning after having the breakfast or lunch. That is called. So they are maintaining that kept on nothing but our meal is a variable which can kept constant in the morning. Okay. So our relationship between the two variables like this. So we can estimate the relationship between the demand and price when other things are remaining constant. Nothing but income, taste, preference will be constant. So when we consider only two variables, that is called partial correlation. Partial correlation. Generally, when you are talking about your friends also, you will talk that relationship between the two variables. When we are ignoring the relation, for example, if the three friends are there, so generally we will talk about what is the relationship between the two persons. The relationship is different. When the other person is joining the group, the relationship is something. Nothing but the group activities we will see. The performance levels also we will measure by using this partial correlation. In group activities, if somebody will join who is against the another person, so other person may not do when other person can join. So the performance will be come down like that. This partial correlation will be used in the management field also. Here the relationship between demand and price when income and other variables are constant. as I told you. Then last one, zero correlation. What is zero correlation? If there is a no relationship between the variables, is called zero correlation. For example, when there is no correlation between the variables, that is called zero correlation. Zero means nothing will be there. Okay. So if there is no correlation between the two persons, is called, or two variables, is called zero correlation. Zero correlation. Can you give any example? So, for example, when you draw the diagram like this, you may not come to conclude that whether which direction is there, which correlation is existing. So, if you like this, it is a positive, it is negative, it is constant, or it is not linear. So, by looking at this diagram only, we can come to know that. So, there is no correlation existing between the variables. If you calculate the values, you may get some values, but which is very weak and weak. Very weak and weak value, we will get it. Okay. So we'll conclude that there is a zero correlation existing between the x and y variables. Can anyone give the example of this zero correlation in our economics? Generally, if you take the data of rainfall and number of births of children, so if the rainfall increases, the number of children may be increases, but in our economics there is no relation between the two variables. But if you take the data, you will get the values. But in our economics, we need to assume, or we need to think whether there is a relationship is there or not. Nothing but, so as the rainfall increases in particular year, the number of children also maybe increases. But exactly in reality, there is no really much relation between that rainfall and number of children's birth. Is it clear? Have you got the point, dear students? Hello? Somnath, Anirudh, and others, Niharika, and other people. See,
No, sir. Can you?
is it not clear?
No, sir.
So it means that, for example, if the rainfall increases, the number of children also increases. Okay. So in reality, there is no relation between the two persons. For example, if number of hours studying, your studying hours will be increased, your marks may be increased. There is a relation. Okay. But if the rainfall increases, your marks may not be depends on rainfall. But there is no relation, right? Like this, if the rainfall increases, the number of children is increases. But in exactly in reality, there is no relationship between the rainfall and number of children's birth. Okay, clear? So this is the zero correlation. So R values lies between minus to 1. See, if R value is a plus, there is a positive perfect correlation. The minus, there is a perfect negative correlation. If R is equal to 0,